All right, in this video, we are going to do the transformations for these trig functions over here, and then we're going to sketch them using a mapping rule and a table of values. So for the purposes of this question, I'm just going to use my transformations as A, B, H, and K. And sometimes you can have A, K, D, and C as well, but for this video, I'm just going to do it like this. Yes, that's how the student requested it. So let's start with describing transformations for this over here, over there. A is 3, B does not exist, which means B is 1, so technically there's no transformation there. H is 1, both signs are negative, and K is 2. So let's describe these transformations now in words. So A is a vertical stretch or compression since it's larger than 1. So vertical stretch by a factor of 3. B has no transformation, so I'm not going to mention that. That's horizontal compression or stretch. H is a horizontal translation, and if it's positive, it means I'm going to the right. So by 1 unit right. Then K is up or down. Since it's positive, it means it's going up. So vertical translation by 3 units. Oh, sorry, 2 units. Up. Next, I want to come up with my table of values to figure this out. So first things first is I want to come up with my original table. And your original table will depend on your parent function. In this question, our parent function is a cubic function, and for both questions, so my parent function is x cubed, y equals x cubed. For an x cubed function, you always take the x points as -2, -1, 0, 1, 2. For each individual function, you have a different set of x values, but that's what you take for x squared, for x cubed, for x4. Basically, all polynomial functions have those x values. To find the y values, all I have to do is cube all of these values because that's my parent function. So -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So that's my parent function over there. Now I have to do my transform function. And to do my transform function, I'm going to do my mapping rule. So my mapping rule is simply right here at the bottom, x, y transforms to x divided by b minus h, and then y transforms to ay plus k. So simply speaking, I just need to solve in my b, h, a, and k for my mapping rule here. So I'm going to do it in this table over here. There's no b value, so I just have x, then my h value is just 1, so x plus 1. Oh, I think I might have messed up my formula here. Is this x over b plus h or minus h? It is plus h. I accidentally wrote that as a minus there. It's x over b plus h. It's minus in just the transformed equation. That's x plus 1, x plus b, x plus h, no b value. And then my a value is 3, so 3y plus k, which is 2. So now all I gotta do is transform these points here. For the x values, I'm just adding 1 to them. So that's pretty easy. -1, 0, 1, 2, 3. For the y values, I'm subbing in the y values into y over there. You can do that in your calculator. I'll just do it in my calculator to be extra careful. So negative 22 to oops, I think I made a typo there. Not 2, sorry. Negative 1. This one's 2. 5. 26. So I just subbed in all these y values in this formula here, and I got the new y values. And now I can just plot these. I'm just going to do a sketch. I don't want to spend the time to put it on graph paper. So I'll do a quick sketch of this over here. Negative 1, negative 22 is down all the way over there. 0 and negative 1, 1 and 2, 2 and 5, and then 3 and 26. So those are my 5 points there. If you do it on graph paper, it's obviously going to look more accurate. The point in the middle is always the inflection point. That's the important thing to remember. So your graph is going to look something like this. I'm not really going to label the points on the graph because you have them right there in the table, but if you were sketching it freehand on your test, you would label all the points like negative 1, comma, negative 22, so on and so forth. You would label all 5 points. If you were doing it on graph paper, should be a bit more accurate. Okay, so let's try it for this second example over here for a bit of practice. In this one, I have no a value, so a is just 1, k is negative 2. Oops, not k, sorry, b, mixing that up with the other format. H is negative 1 because it has to be the opposite of that, and k is just that value there, which is negative 3. So no vertical stretch or compression. My k value is negative. If your k value is negative, that's always a reflection in the y-axis. If your a value is negative, it's a reflection in the x-axis. Now my k value is 2. If your k value is greater than 1, you don't count the negative, just looking at the value itself. The negative is the reflection. If that's greater than 1, it's a horizontal compression by a factor of, and you got to flip that number upside down, so 1 over 2. Only some schools do that. Maybe yours does, maybe yours doesn't, but usually they do. H is a negative 1, which means we have a horizontal translation by 1 unit left. K is negative 3, which means we have a vertical translation by 1 unit down. I'll do my table of values next. Since it's a cubic function again, the original table is the exact same. Just going to copy that down from there. Then I will do my mapping rule. So over here I have a horizontal compression by a factor of 1 over 2. And my k value, my b value is negative 2. So I have x over negative 2, x over b plus h. So plus negative 1 is just minus 1. Then I don't have a value, so 1 times y is just y, and then plus k, so minus 3. So now let me translate all of these. We're going to get some decimals here, but I'll do it in my calculator. Always best to use decimal values for graphing because they're easier to plot. And then for the y values, I just have to subtract 3. That's pretty easy to do. Now I can plot out these points over here. Again, I'm just going to do a sketch. Zero and negative 11, negative 0.5 and negative 4, negative 1 and negative 3, negative 1.5, negative 2, and then negative 2 and 5. So approximately like that. Doesn't have to be super accurate, but if you do it on graph paper, it'll look a lot more accurate. Draw it about the inflection point always. Makes it a bit easier. And your cubic function should look like that. You can label the points as well. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.